the brain burns calories. The harder you think, the more calories your brain burns. Mental fatigue, where it comes from, why it happens, and what you can do about it. Our brain actually burns about 20% of the entire body's caloric pool. When you're engaging in very difficult mental tasks and critical thinking, your brain actually does burn more calories, quite a significant amount, believe it or not. Now, those calories that the brain burns are not reflected by blood glucose in the body, systemic blood glucose. It's specifically local to the brain and specific regions of the brain. When they took rats, right, and they had one level of maze that was a 3-arm difficulty and the other level that was a 4-arm difficulty, let's just say the more difficult maze increased the amount of spatial working memory by 50%. Now, that more difficult maze dropped the blood glucose in the brain by 30%, as opposed to the less difficult maze, which was about 11%. And then when they added glucose to these rats, it actually enhanced the cognitive function in the rats where their glucose was depleted to a significant amount, but not the other rats. So what's interesting to note is that in Alzheimer's and hypoglycemia, they actually have reduced cognitive function. And then when they're also given glucose, it can actually enhance cognitive function of those people. But I don't think giving glucose is the best solution for replenishing the stores of glucose in the brain, because if you struggle with insulin resistance or hypoglycemia, continually giving someone glucose doesn't exactly solve the problem. It kind of feeds the cycle of hypoglycemia to just return again. This is where gluconeogenesis comes into play. Gluconeogenesis is essentially how your body makes fuel out of a non-carbohydrate source. For example, the ketogenic diet, when people eat protein, gluconeogenesis increases your blood sugar from that protein. But it's rate limited and it doesn't go in excess of what the body needs. So it's completely adaptable. The more protein you eat doesn't mean that your blood sugar goes higher and higher and higher. It just goes exactly to where the body needs. Now, what's interesting is that astrocytes in the brain, astrocytes essentially regulate electrical impulses within the brain and supply energy for neurons, and they actually are capable of gluconeogenesis within the brain. So there is de novo synthesis of glucose within the brain. When you think really hard for a very long period of time, there's actually a lactic acid buildup in the brain. Kind of like how when you're working out at the gym and you use your muscles really, really hard, you build up a lot of lactic acid. It's hard to use your muscles, they're really sore. That actually happens in the brain. And that lactic acid is actually a substrate for gluconeogenesis, which prevents it from forming a very toxic buildup in the brain. But what if we have an excessively high demand and gluconeogenesis isn't keeping up? So there's something called PEP carboxykinase, and increasing the expression of this enzyme can actually increase the rate at which gluconeogenesis occurs. So there's a few things that can increase this expression. One of them is glucagon and the other is cortisol. So with glucagon, there's something like intranasal glucagon, and that's something that people take when they're going into a diabetic coma, a very severe hypoglycemia, because it raises the blood sugar back up. But a better option might be supplemental biotin, which has been shown to increase the expression of glucagon without affecting fasting blood glucose or glucagon resistance. And another thing that could work as well is, because we talked about cortisol, is taking cold showers. So that can increase cortisol, which can increase PEP carboxykinase expression. You even see it in movies when someone splashes their face in the sink to kind of wake up, right? That's cortisol. And cortisol is not always bad. It can actually be really helpful, especially when it comes to cognitive function. And another thing about gluconeogenesis and a ketogenic diet, especially for cognitive mental tasks or prolonged cognitive mental performance, is that proteins increase glucagon. And they don't increase insulin as much. They do increase insulin somewhat, but they increase glucagon significantly. Whereas carbohydrates increase insulin a lot more than glucagon. So this is the kind of thing with diet manipulation. When you're doing your mental tasks and you're doing all your mental work, that's a good time to eat protein, or protein and fats. And then when you're done all your mental work, that's a good time to eat carbohydrates, like when you want to relax and bring tryptophan into the brain or after a workout. It's for a relaxing time. I think the ketogenic diet is very useful when you're really trying to perform mentally. What I've noticed is that when I've done the ketogenic diet, I don't really get a crash. I don't really crash that easily. I have sustained mental energy levels. So I think it's very useful. Yeah, this is some of the science behind it. And, with biotin and cold showers, maybe there's some other methods too that you guys know about. We can really improve the function of gluconeogenesis in order to supply more glucose for those higher faculty mental functions in the brain. So yeah, there we have it. The brain burns calories. The harder you think, the more calories your brain burns. If you guys want to learn about some other kind of stuff, just leave it in the comments and I can do some research on it. Or let me know what kind of things work for your mental performance boosts, aside from just typical stimulants. Okay guys, keep it straight.